Assalamu alaikum. I am MD Ashiqur Rahman, working as a lecturer in the Department of EEE of Green University of Bangladesh. I shall discuss on the research article, Statistical Thermophysical Simulation of a 3D CAD Model of Human Eye. The research article is co-authored by Mamun Rabbani, lecturer in the Department of Biomedical Physics and Technology of the University of Dhaka. The presentation is divided into the following sections: introduction, motivation, research objectives, methods and materials, results and comparison, and conclusion. Eye is an important organ of human body. It is one of the blessings of Allah subhanahu wa ta'ala for the humankind. It is observed in the literature that anomalies of human eye can be caused by thermal damage, and temperature profile can be useful to find the causes of these anomalies. But human eye is very sensitive to external contact. The contactless measurement of temperature cannot provide much information about internal eye tissues. In this regard, computer simulation can be helpful to visualize and predict the temperature profile of whole eye. To conduct this research work, we are motivated by the following facts. In the literature review, it is observed that exposure of infrared radiation may lead to the formation of cataract. It is also observed in another research work conducted on the mouse ocular surface due to the exposure of LED light that overexposure of blue LED can cause oxidative damage of cornea. In another research article, we have found hypothermia treatment of eye using laser may lead to the damage of ocular tissues. In another research article, it is found that blue LED is responsible to disturb the sleep cycle of human body. Thus, we need a normal temperature profile of eye based on which the extent of variation can be determined to consider it harmful. Throughout this research work, we have tried to achieve the following objectives: to develop a 3D model of human eye using SolidWorks. Second, to develop the temperature profile of eye using finite element method, or in short FEM, and considering normal physiological conditions of blood flow and metabolic activities of eye tissues at ambient temperature of 298 Kelvin or 25 degrees Celsius. And finally, to validate the developed 3D model to conduct further researches on eye. The methodology developed will be discussed in the next 3 slides. First, the geometric model will be discussed here. We have developed a 3D computer-aided design of human eye using SolidWorks. The 3D model has 7 homogeneous regions, including lens, aqueous humor, cornea, iris, ciliary body, vitreous humor, and sclera. The 3D model is 24 mm long horizontally, and it is 22.4 mm long vertically. The dimensions are taken from the literature review. In our simulation, we have utilized Payne's bioheat transfer equation. The governing equation is shown here. The equation balances the rise and loss of heat in the ocular media. The blood perfusion activities and in the biological tissue are represented by the second term of LH, left hand side, where the TBL is the blood temperature and the Q represents the metabolic activity of human eye. In this equation, the term on the left hand side corresponds to the temporal variation of temperature within the eye. And in case of steady state phenomena, we can neglect the temporal variation of temperature, and the final governing equation used in the simulation is shown on the last line of this slide, where QMT corresponds to the metabolic activity of human eye. Boundary condition is applied at sclera. The governing equation of this boundary condition is shown here. The first term corresponds to the convective heat flux, while HAMB corresponds to the coefficient of convective heat flux, and TAMB corresponds to the ambient temperature. The second term represents the radiative heat flux between the cornea and external environment, and the last term E corresponds to the tear evaporation rate. At the surface of cornea, the heat gets lost due to the surrounding environment due to the conduction, radiation, and evaporation of tear. Second boundary condition is applied at sclera, and the governing equation is shown here. HBl is the coefficient of convective heat flux, TBl is the blood temperature. At sclera, blood flow creates a convective heat flux from blood stream to the ocular tissues, and the resulting heat spreads throughout the eyeball by conduction. The results of this simulation will be discussed here. As discussed earlier, cornea is the outermost layer of human eye, and sclera is the innermost layer of human eye. Cornea interacts with the external environment, and there is a heat loss occurring at cornea, and at sclera there is blood stream in those eye tissues. So at sclera, the temperature is close to the blood temperature, which is equal to 310 Kelvin, and at cornea, the temperature is observed to be minimum of 307.45 Kelvin. The temperature variation along the horizontal axis of eye from cornea to sclera is shown here. This point correspond to the tissue of cornea, and this point correspond to the ocular tissue of sclera. This graph is obtained by considering the straight line, by considering the temperature along the straight line shown on in this eye diagram. We can observe that in the anterior portions of human eye, the temperature is lower compared to the posterior portions of human eye. Two-dimensional isothermal contour is shown here. This region corresponds to lens, and the cornea is indicated here, the outermost layer of human eye, and sclera is the innermost layer of human eye. From this isothermal contour, it is observed that temperature within the eye changes mainly from lens to cornea, and the variation of temperature from the posterior surface of lens to the boundary of sclera is relatively small. This temperature profile is this phenomena is due to the fact that at cornea or at the anterior portions of eye there is a heat loss occurring at cornea, and thus the temperature variation or the low temperature is observed at the anterior portions of human eye. The obtained result will be compared with the existing FEM simulations in this slide. The comparison is made considering the 298 Kelvin of ambient temperature. We have considered the temperature on the surface of cornea to make the comparisons. In the first two references, the research work conducted considering the 2D geometric model of human eye, and thus they utilized comparatively simplified geometry, and they do not incorporate the practical behavior of human eye properly. And in the next two reference, the research work conducted is utilizing both the 2D and 3D geometry, but they have neglected blood flow and metabolic activities. Thus, this is one of the limitations of those two studies, and they cannot also incorporate the practical behavior of human eye properly. The last two references, chapter 14 of reference 1, utilize both the 2D and 3D geometric model, and they found the temperature on the surface of cornea to be 305.5 Kelvin in the case of 2D geometric model and 308.7 Kelvin in the case of 3D geometric model. These values differ greatly from the mean value of the literature. The mean temperature in the literature is observed to be 307.81 Kelvin. In our study, we have utilized 3D geometric model. We have considered blood flow and metabolic activities, and found the temperature on the surface of cornea to be 307.45 Kelvin. Thus, the present study incorporates more practical behavior of human eye. In conclusion, we can say that the research work portrays the thermophysical phenomena of human eye quite well, thus achieving the objective of this work. The developed methodology will be useful to develop the temperature profile of eye for different diseases and aging of eye tissues. And the results of this research work will be helpful to distinguish between the healthy and the sick conditions of human eye. These are the references utilized in the comparison section. So thank you everyone.